This is section 13.6, which is our last section before our next test. It's about circles still, so our objective for this section is write equations that correspond to circles. So I know we've been working with chapter 10, but we're going to throw 13.6 in here since we're still talking about circles. So before we go too far, we need to review a couple of formulas that you'll need for your homework. Midpoint formula is you take the x-coordinates of your points and divide by 2. Then you take your y-coordinates and add them and divide by 2, and that is your midpoint. Distance formula is right here. It's the differences of your x's. So we subtract them this time and square them. And we're going to add our y's being subtracted and square them. For here and in distance formula, so both midpoint and distance, it does not matter the orders of the x's and the y's so long as x comes first and y comes second. Same thing here. X's come first, y's come second. So our one and only theorem for this section is theorem 127, and this states that if the equation of a circle whose center is hk and whose radius is r is x minus h squared plus y minus k squared equals r squared. If you notice, my center are both positives h and k, but when they go into the equation, they become negatives. So whatever your center points are, whether it be positive or negative, when you write the equation, they become the opposite sign. So if it's positive in the center, it becomes negative in the equation. And if it's negative in the center, it becomes positive in the equation. You need to remember that. So let's see how this works. We want to write an equation of each circle, and I have two different problems here. So the first one is we're given the center is 1 and 1, 4, and the radius is 15. So to write this, we start with x minus, because it's positive 1 here, it becomes a negative 1 in the equation, squared, plus same thing for y. We do y. Now this 4 is positive in the center, so it becomes a negative in our equation. Square this, and is equal to our radius squared. So, which is, we'll write on the next line, so we'll do x minus 1 squared plus y minus 4 squared is equal to 225. So you could have skipped this first step and just written it like that. That's completely fine. Here's just showing you what we did for each one of them. So in this next one, same thing. We do x. So if you can't remember, we always put x and then y. So x here is negative 10. So when we put it in the equation, it flips signs and becomes positive 10. We square that, and we're going to add our y's now. So y, negative 3, it's a negative number, so it comes down here as a positive number. Squared equals my 9 squared. So that's my radius squared. So my final answer is x plus 10 squared plus y plus 3 squared equals 81. So not too bad, little challenging, but not a whole lot. If you just remember that whatever is in the center, it goes the opposite sign in the equation, and it's always equal to our radius squared. So for the next one, here we're given the equation and told to identify the radius in the center. So to identify the center, you need to look at these two numbers right here. And we always look with the x first. This is a positive 6. Now remember, when you go either way, it flips signs. So I have a positive 6 here, it becomes a negative 6 in my center. Then I look for the number with the y. That is a negative 6, so it becomes a positive 6 for the center. Then for the radius, we look at this last number. And because it was r squared in the formula, we square root it. So my radius is a square root of 25, which is 5. So let's do the same thing for this next one. Again, look at the two numbers inside the parenthesis. So my center is we flip the sign with a negative 16 to make it positive 16. Positive 1 becomes a negative 1 for my center. And my radius, we look at the last number. So my radius is the square root of 5. Now we can't simplify that, so we're going to leave it as a square root of 5, but on your homework, if you are able to reduce the radical, please do, because that's what we've been working on. In the next ones, we are graphing equations. So you're going to use what we just did. We're going to find the center and the radius first, and then we're going to plot the points. So to find the center, remember we look at the two numbers inside the parentheses. So my center is going to be the opposite of positive 4, which is negative 4, and the opposite of negative 3, which is positive 3. And my radius, we look at the last number, so my radius is equal to the square root of 1, which is 1. So to graph this, we're first going to graph the center. It's negative 4, 3. So we start in the center, and we go to the negative 4, and we're going to go up 3, and we're going to plot a point. So center first, and we're going to do the radius. So the radius means that in every single direction, our circle is 1, or our radius is 1. So I'm going to go right 1, up 1, left 1, down 1, and then I'm going to make a circle connecting these dots. Now don't worry if your circle doesn't look perfect. I mean, look at mine. That's not perfect at all. Just try to make it look as circular as possible. And then we're done. That's it. That's all you do. So let's do on the next one. Let's look at the number with x. Since there's no number here, the only number that represents nothing is 0, and 0 is its own sign. It's neither positive nor negative. Then we look at the negative 4 with the y, and it comes down as a positive 4 for the center. And then my radius. My radius is the square root of 9, which we know is 3. So let's graph this. My center is 0, 4. So I start at 0, I go up to 4, I'm going to draw a dot. My radius is 3, so in every direction I'm going to go 3 and plot another point. So I went right, go back to my center, go back up 3. Back to my center, go left 3, back to my center, and down 3. Now the circle is going to be a little bit bigger, so hopefully mine will at least catch the dots. Again, remember, circles don't have to be perfect. I mean, look at mine. Mine is definitely far from perfect. Yours will probably look a whole lot better than mine, so don't worry about it. But all you do is just connect the dots. You can even erase and make it more perfect if you like. So in the next examples, you have to determine based on a point and an equation if this point is inside the circle, outside the circle, or if it is on the circle. So what you're going to do is you're going to plug in this 3 and this 6 in for x and for y, and you're going to solve it all the way through. So we get 3 minus 2 squared plus 6 minus 4 squared, and we want it to equal 5. So we're going to see how it compares to this 5. So 3 minus 2 is 1, so I get 1 squared plus 6 minus 4 is 2, 2 squared equals 5. Well, 1 squared is 1, 2 squared is 4, and 1 plus 4 is 5, so 5 is equal to 5. Because these are equal, and only because they're equal, we can say this is on the circle. So if you go through all of this and you get the same number, so 5 is equal to 5, then that means our point 36 is on the circle. So let's try it with the second one. So we're going to plug in this 0 and this 0 in for x and for y. So we get 0 squared plus 0 squared equals 10. Well, 0 squared is 0, 0 squared is 0, and 0 plus 0 is just 0. So 0 equal to 10. Well, we know that's not true. And since 0 is less than 10, that means this is inside the circle. So it's not on the circle and it's not outside the circle. So if it's on the circle, you'll get numbers that are equal to each other. Inside the circle, you'll get a number that's less than the number we started off with. And I guess you can guess, if it is greater than, that means it's on the outside of the circle. And you'll have a couple of problems like that on tonight's homework. So in the next one, we want to find the center and the radius of the circle represented by each equation. Now, these equations are not set up like the ones we've been working with. So we have to do what's called completing the square. And you should have seen that in algebra, but just in case you forgot, we're going to go over it again. So what we're going to do is we're going to work with just the x squared plus 4x right now. So I'm going to rewrite this so that I have x squared plus 4x plus some imaginary number that we're going to find here in a second. And I'm going to do the same thing for my y's. So let's add those. So plus y squared minus 6y plus imaginary number, because we don't know what it is yet. And this is going to be equal to 14 plus our first random number plus the second one, because whatever you do to one side of the equation, you also have to do the second one. So to find each one of these, so to find this right here, we're going to take this number. So whatever's attached to the x, so in this case it's 4, I'm going to divide this by 2, and I'm going to square it. So 4 divided by 2 is 2, 2 squared is 4. So 4 goes here on both sides. Do the same thing for the y's. My number here is negative 6, so I do negative 6 divided by 2, square it as well. So negative 6 divided by 2 is negative 3. Negative 3 squared is a positive 9, so we're going to add 9 to both sides. So to complete the square, that is completed the square, so to factor it, because we want it in x plus or minus something squared, so I want it in just one parenthesis. I'm going to have an x. Then you're going to look at this number right here, whatever you got inside. So what is 4 divided by 2? Well, that was 2. So this is x plus 2 squared. So this number came from that. So plus y. Now what is negative 6 divided by 2? Well, it was negative 3. So negative 3 goes inside. So negative y minus 3 squared. And that is equal to, well, what's 14 plus 4 plus 9? Well, 14 plus 4 plus 9 is equal to 27. So here we have it. Here we have our equation. So our final answer after we're all done is x plus 2 squared plus y minus 3 squared is equal to 27. So what we need to do from here is find the center and the radius. So to find the center, we look at these two numbers right here. So center, we take the positive 2, when we put it in the center, we flip it, so it becomes a negative 2. And our negative 3 becomes a positive 3. And then my radius is equal to, it's the square root of this number, so square root of 27. Now this time, 27 can break down. 27 breaks down into 9 times 3. So this becomes 3 square root of 3. So my center is negative 2, 3, and my radius is 3 square root of 3. You will have problems on your homework that have to deal, or that you dealing with completing the square. So make sure you come back to this if you struggle with the completing of the square. And our last example, same thing, still find the center and the radius, but in this case, our equation is not set up all nice and neat. We have to get everything on one side. So I need to move this 4x to the other side, so I'm going to subtract 4x from both sides. And I also need to move this negative 10y, so that means I'm going to add 10y to both sides. And I want to leave this 12 alone. I want the number on that side. So when I rewrite this, I get x squared minus 4x plus, I'm going to leave that blank spot because I want that number there, plus y squared plus 10y plus, again, the blank spot, because we've got to complete the square, is equal to 12. So, well, 12, we're going to make sure we add our two imaginary numbers. Do not forget to add them, because if you do, then the whole entire equation's off. So to find this number right here, we take our number right here, negative 4, divide that by 2, and we square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is just 4. Well, that was easy, so we add 4 to both sides. Do the same thing for this number right here. So this number came from number attached to the y, which is 10, divided by 2, squared. So 10 divided by 2 is 5. 5 squared is 25. So we add 25 to both sides. So our final answer will be x. Now to find the number that comes here, we take what number was inside the parentheses. So negative 4 divided by 2 was negative 2. And we square that. Plus, same thing for y. 10 divided by 2 is 5. So add 5, square that, is equal to, well, 12 plus 4 plus 25 is 41. So now we need to find the center. So to find the center, again, we look at the two numbers inside the parentheses and we switch their signs. So negative 2 becomes a positive 2 for my center, and positive 5 becomes a negative 5 for my center. And then my radius comes from the last number, the one that's all by itself, and that is the square root of 41. Now 41 is what we call a prime number, so we can't reduce that any further. So it just stays the square root of 41. So if you have any questions, if you're still confused on any of this, then go back to the beginning, watch these examples again, because these are the kind of problems that are going to be on your homework, so it'd be very beneficial if you look over them and try to understand some of them before you come to class. But if you have any questions, make sure you fill that out on the quiz, and I will do my best to answer them when class starts. So the 2 questions that go on the quiz. Here is one of them. Write an equation of this circle. This is almost exactly like the first examples we did. So go back if you need to slide 4 or page 4, and remember in the center you switch the sign when it goes into the equation, and the radius becomes a squared number. So make sure you write the equation. When you write it though, you're going to write parenthesis x plus something, a number, parenthesis. To get the exponent on your computer, you're going to use this little caret key. It's the one above 6, so you'll have to hit Shift 6 to get this, and then you'll do a squared. That way I can see the squared in the formula. And then the second one is find the center and the radius of the circle represented by this equation. So this is just like the problems that we just did the last one, where you have to do completing the square. So make sure if you struggle with those, you go back and watch those examples again. And remember, if you have any questions, please fill it out on the quiz, and I will try to answer those questions when class starts.